Welcome back to machine learning. In this lesson, let us learn about supervised learning and unsupervised learning. Supervised learning. What is supervised learning? Supervised learning is a machine learning approach that defines by its use of labeled datasets. These datasets are designed and trained as supervised or as algorithms to classify data or prediction outcomes accurately. Using labeled inputs and outputs, the model can measure its accuracy and learn over time. Yeah, here is an example of a labeled data set. We can see we can label here is the label position, experience, skill, country, city, salary. Here is the labels things, and this is the data which correspondingly develop a position developer like this and experience like this and labeled it is beautifully. Current country is labeled and city is labeled and salary is labeled. It is the labeled data set. We can with this data we can uh, it is called supervised data. Supervision can be separated into two types problems for data mining: classification and regression. Classification problem uses an algorithm to accurately assign test data into specific categories such as separating apples or oranges, or in a real-world supervised learning algorithm can be used to classify SAM in a separate folder by inbox linear classifier. Support vector machines, decision trees, and random pairs are all are common type of classification algorithms. Regression is another type of supervised learning method that uses the algorithm to understand the relation between the dependent and independent variables. Regression models are helpful to predicting per numerical values based on the different data points such as sales, revenue, projections for a given business. Some popular business regression algorithms can be linear regression and logical regression and polynomial regression. Here is the labeled data set we can see here. It is a labeled data set. We can see here some maroon color and blue color. You can see uh, it is a beautifully labeled data. Where is the unlabeled data? Same color. It is not unlabeled data. It is unlabeled data. Its color is labeled. It is not color labeled. And human will be A will be think like this and pseudo label data. It is a pseudo label data and label data. Trying the model with the pseudo and label data sets together. Here is an example of label data. We can see cat and dog. It is the label data. It is unlabeled. It is unlabeled, which is quite confusing. It is either it is a dog or it is either it is. However, mission will be not recognized automatically. We will give some feedback to this. Either it is a label data set. We have to give some labels. We can see here is an example of unlabeled dataset. It is raw data. It is unlabeled data, and by using the algorithm clustering algorithm, some algorithms, unsupervised algorithms are there. Clustering things are there. It will automatically cluster into same similar objects. Its groups similar objects. We can see here triangles are grouped here, and some rhombus are grouped. Say cubes are here, and some circle like bodies are outputs are classified like this. It is unsupervised classification. It is clustered like this. Previously, we have clustered like triangles. These things, rhombus and this thing, circles. Like this, it is clustered like blue points and this green points, some red points. Like this is our unsupervised learning. It's a called clustering thing. Supervised learning. It is a supervised learning. This supervised some independent variable and dependent variable with this linearity is increasing with supervised. We can see it's a regression problem. It is a regression problem, classification regression problem. Here is a raw input data with uh, some raw input with these things and training data and dataset. algorithm will be output will be like this. Of the cluster raw data will be labeled here, and it is will be easily classified. Some processing involves something labeled data and labeled data. Is it is the labeled data and model, and predictions will be line dog test data. This here is the processing of this thing. How processing involves this machine learning processing. We will give some training mode data, and we will make some predictions uh, line dog with the test data. We will use some test data so that we can evaluate the model. Types of supervised learning. There are various types of supervised learning algorithms such as linear regression, logistic regression, supportive estimation, multi-class and decision trees. Here is the linear regression problem. We can see moreover linear regression is used to determine the character and strength of the association between the dependent variable and series of other independent variables. It helps the creates a model to make predictions such as predictions and company stock price. Here we can see here is the some data. We can see x and y plot as a linearly increasing. It is a linear regression. It is called. By using this data, we can predict this thing. Later, we can predict these values. Y is equal to mx plus c by applying this formula. Linear probable defining this linear regression model. There are parameters b0, b1, b2 are the such as fixed values depending on the variables. This variable is random variable x is the model of equation. Y is equal to b naught b1, so beta naught beta x and beta c. The quantity epsilon is the model equation is error a random variables. Epsilon is equal to 0 and epsilon is 2 is here is an assumption here. A linear probability model. X is an independent variable and prediction the expression variable, not random. Y is a dependent variable response of the fixed y will be random variable. The random deviation from the error. Epsilon it is some random error. Fixing this will be variable. What exactly does do? Here is the linear regress problem. Here you can see here is an error from here is my fit. Here is data points and we will fit like this. Here's an error. This is an error like this is g epsilon 1 epsilon 2 error call error. The true expression is y is equal to beta naught x beta naught plus beta 1 x. A linear probability model. How do we use simple linear regression is appropriate? In statistics, statistical model is a statistical model that that model probability of an event taking place by having log odds or even be linear combination of one or more independent variables. In regression analysis, logistic regression is estimation of the parameters of a logistic model. The coefficient is in linear combination. Graph of a logical regression curve fitted y x y data. The curve shows the probability of passing exam versus studying. This is the logical regression model. Uh, by it's a binary value. It is not a binary value. It is one value and it is one value. It is called binary values. You can see this logical regression is equal to px is equal to prediction is equal to 1 by 1 plus e power minus x minus u by s. P of x is equal to probability is log where we use the location parameter. P of x is equal to 1 by something is we can see here where intercept is calculated here. Here is a regression like this regression logical regression application. Logistic regression is used in various fields, including machine learning, most medical fields, social sciences, for example, trauma and injury services, which is widely used to predict the mortality of injured patients, was originally developed by Boyd and using logical regression. Many of the other medical scales and used to assess severity of a patient have been developed using logical regression to predict the risk of developing given disease. Based on the characteristics of the patient of various blood test etc. Another example might be predict the whether Nepal's water will be hot Nepal Congress community part of Nepal or another party based on the income. The techniques can be also be used to engineering and especially predicting the probability of failure given system. In economics, it can also be predict the likely of the a person's ending up within a labor force and business application, which would be predict the likelihood of the home owner defaulting any mortgage or conditions, random fields or expressions, logical regression. These are some of the applications. There is some problem you can give. That's all about the um, supervised and unsupervised learning. Thank you.